Hello, Algebra 1. This is our first video in our new virtual learning environment. I am going to just record a video over all of this first section of our new unit that we actually started on the Friday before spring break. So if you would like a refresher, this is a good way for you to get that refresher. And we can just go from start to finish. So our next unit is called Exploring Quadratic. Actually, I'm sorry, our next unit's not called Exploring Quadratic Graphs. It is called Quadratic Equations, and this is part 1. So our goal this unit is to graph them. Our goal of this section is to just learn new vocabulary because there is a lot of new vocabulary involved. Okay. So what we started with was a lot of new vocabulary. So the first thing that I had us define was what is a quadratic function? So a quadratic function is a function that's largest degree or exponent is the number 2. We also talked about parent function. We worked a little bit on an activity with this. A parent function of a quadratic function is y equals x squared. So the next thing we looked at was which of the following of these functions is quadratic. So when we're determining that, we are wanting to specifically have the largest degree be 2. So as you kind of scan through here, if we look at letter A here, if I look at the variable, the exponent on the variable, remember there's really an imaginary 1 right there. So that is not the number 2. So this is not a quadratic. In fact, this is a linear. I'm going to write the word linear underneath it. This is actually a linear function. Letter B, if I were to look at the exponent is the variable x. That is not the number 2. So this is not linear, but this is exponential. I'm just going to abbreviate exponential here. Remember what this, when we graphed these, it gave us this curve that ended up looking like this. I'm going to make my pen a little bit smaller. Oh, there we go. That's what I want. Letter C. I see degree 3 and degree 2. And I'm looking, actually, I take that back. I only have degree 3 because the degree is the largest exponent. So this is not quadratic either. In fact, this is called a cubic. You will learn this when you go into Algebra 2. Letter D. I want to look at the power 2. This is quadratic. All right, so I'm going to go ahead and circle D. If I look at letter E, largest degree is power 2. This is also quadratic. And then if I look at letter F, power is x. This is not quadratic. This is another exponential. All right, so that is kind of some of the basics of a quadratic. Okay, but let's go on. Oops. All right. A little bit of vocabulary here. So our next item was defining a parabola. So I'm going to do a little highlighting here. So a parabola is the graph of a quadratic function. It is always a U-shaped curve, and you can see on the paper there is a picture of a parabola. In fact, that parabola is considered the parent function. Okay, so that is what we are going to be graphing this unit. The word parabola also is a new word for you. So we want to get in the habit of saying that properly with parabola. All right, so let's do a little vocabulary. I'm going to do a lot of zooming in and out here so that we can, I can write on this so that you can add to it if you need to. All right, so the very first item here, parabolas are symmetric. Parabolas are symmetric. All right, so you can fold it so that the two sides exactly match. So if you take a look at this U-shaped graph, if I were to fold vertically, fold over this vertical line, this right-hand side would perfectly match the left. Okay, second item here. Oops. The fold line that divides the parabola is called the axis of symmetry. The axis of symmetry. You're going to have to bear with me on handwriting. I'm trying to use a stylus here, and it's not the best. All right, now the axis of symmetry is also abbreviated AOS, okay? And it is written in the form of an equation. It's written in the form of x equals some sort of number. So the axis of symmetry up here, I'm going to write AOS is the equation x equals 0. Okay, so the vertical line through the origin is right here, goes through 0 on the x-axis. The vertex is the point on a parabola that represents the maximum or minimum value. Maximum or minimum. Okay, the top or bottom. The vertex is on the axis of symmetry. So this dot right here that I previously wrote, it's on the axis of symmetry. All quadratics in the form of y equals ax squared have a vertex of 0, 0. It's always going to be in the origin. Okay, so 0, 0. Last couple of items here. If a is positive, the parabola opens up and the parabola opens up and the vertex is a minimum. Skipped my I right there. Let me fix that a little bit. I don't like how that turned out. Let's try that one more time. Minimum. Okay. So remember, the A value is referring to this number right here in front of x squared. So if it's a positive 2, it opens up. If it's a positive 5, it opens up. Okay. If A is negative, if that number is negative, then it's all opposite. The parabola opens down, and the vertex is the maximum. Okay, so if you think about if a parabola is opening down like this, think about your vertex is going to be right here at the top, which is the maximum point of the parabola. Okay, lastly, if the absolute value of A is greater than 1, then the graph is narrower, and we're talking about narrower than the parent function. So it's real skinny. If the absolute value of A is in between 0 and 1, then the graph is wider than the parent function. Okay, so sometimes you'll see graphs that are like really wide like this. Sometimes you'll see them that are real skinny and narrow. All right, so we're just going to get used to that, some of those properties and vocabulary. All right, moving on. Let's look at those three pictures at the bottom. The only thing that I really want you to notice about this, now, first of all, this one here is our parent. So I'm going to write, oh my gosh, sorry. I keep touching the screen with my hand. Parent. Okay. So this is my parent function. This is what I compare wider or narrower. Now, I just want you to notice that the A value here is a -4. So do you see how it's opening down? Okay, it's opening down right here. And so if I go back to that other page, oops, let me find it. If I go back, or you guys just look up a section on your notes, I am noticing that the absolute value of A is bigger than 1 because the absolute value of -4 is 4. Notice how it's narrow. Okay, so when I'm looking at, if I maybe compare these two, this is going to be narrow. Okay, so the other thing I also want you to notice, since it's a -4, it's opening down. So I'm going to put here opens down, and then it's narrow. Oops, narrow. Okay, and then notice how the next one is different. Our A value is positive, okay, so it's opening up. And so it's that the 1/4 is in between 0 and 1. So do you see how it is wide or wider? Okay, so we're going to do a little bit more of that information or that type of explanation here as we look. Okay, let's move on. So what I'd like you to do is I would like you to try this example A. I want you to do two things. You are stating the vertex of the function, number one. Then you're telling whether it's a maximum or a minimum. So I'd like you to pause the video and try to write both of those items down and come back. Okay, the vertex here, I'm going to put a dot where the vertex is located. So the vertex is where the curve turns. All right, so I'm going to put V for vertex. The vertex is at the ordered pair of 1 and -2 in this graph. And then it is at the bottom of the graph, so it is a minimum. Okay. Find your vertex here. I know you're missing part of your graph, but your vertex is the turning point at the top here. So my vertex is at -2, 4. And then it is at the top, so it is at a maximum. All right, how'd we do on that? Okay, let's look at these last two examples. So we are going to do the same two items. We are going to, or the same actually 4 or 5 items. Number one, we are going to graph using at least 5 points, okay? And we're going to use the table of values for that, all right? We are going to state the vertex. We are going to state the axis of symmetry. And I'm running out of colors here. We are going to state domain and range. All right, so our first group of items is 5 points. So what I'm going to start with is I'm going to always recommend, actually I take that back. We're going to start with vertex. So I'm going to take you back in your notes to this piece right here. Right here, all quadratics in the form of y equals ax squared have a 0, 0 vertex. So when I look at this, oops, sorry. Do you see how this is in the form of y equals ax squared? Okay, so that means my vertex is 0, 0. So we always put the vertex in the middle of the table because I'm going to make this U-shaped graph that has symmetry. So if you think about that being an XY axis, the numbers on the left-hand side of the x-axis are symmetrical to the right-hand side. It's just one's negative, one's positive. So here's what I'd like us to do. I would like to put fill in 2 numbers that are under 0, 2 numbers that are above 0. So I'm going to go with -1 and -2, and then back to 0, and I'm going to go with 1 and 2. So now I can fill out the y value. I'm just going to substitute these x's into x here. So I'm going to go ahead and kind of write every detail out for this first one. All right, so I'm going to take my equation and plug it in. So I'm going to plug in the -2. So I'm going to take 2 out of the equation, and then you're going to have to substitute the x value in, and then just do the math. You can grab your calculator, or you can kind of work through this if you want. So this is going to end up being, I'm going to start with my order of operations. -2 squared is 4. All right, so I'm going to take this front 2, and now I'm going to have a 4 here, and so that means I'm going to have an 8. Oops. All right, so I'm going to go through with the next part. So I'm going to have y equals 2, and then we're plugging -1 in this time. All right, so now I'm going to have 2, and then negative 1 squared is positive 1, so I end up with 2. I already know 0, 0. Now plug in the positive 1. So I'm going to have y equals 2 times 1 squared. Well, 1 squared is 1. So we are going to have 2 times 1, and I end up getting 2. Oops, sorry. I end up getting 2. And then if I do one more, I'm going to plug in positive 2. So I'm going to have y equals 2, and then I'm plugging in a positive 2 here. So when we do the math, 2 squared is 4. So I'm going to have 2 times 4, and 2 times 4 is 8. Now, I want you to notice the symmetry. Look at this. When I plugged in, so 0, 0 is my vertex. When I plug in negative 1, I get 2. When I plug in positive 1, I get 2. When I plug in negative 2, I get 8 and 8. All right, so let's graph that. All right, so we've got negative 2, 8. So I'm going to go left 2 and then down to 8. I'm going to go left 1. Oh, you know what? I did that wrong. Sorry. We need to go left 2 and up to 8. There we go. Negative 2, positive 8. Negative 1, 2, 0, 0. 1, 2. And then positive 2, positive 8. All right. And then you are going to make your parabola curve through your points, just like that. Okay. So let's come back over here. Let's do our axis of symmetry. Now, if you look at the first page, it's always in the form of x equals. And so it's always going to go through. Let me go back to my graph. I'm going to put a dotted line in yellow through the origin. It's always going to go through the vertex. And what number on the x-axis is it going through? Well, it's going through 0. So your equation is just x equals 0. Okay, our domain. We did domain and range a little bit ago, and we are wanting to write it with parentheses and brackets. So if you recall, your domain are going to be your x values. Your range are your y values. So when I look at my domain, if I think about a parabola, let me switch colors here. If I think about a parabola being super wide, maybe it goes like this. The widest parabola you could think of. If you think about your x-axis right here, you are going to have every bit of this parabola on the curve is corresponding to the x-axis from this perspective. And it's going to go to the left and the right forever. So it's going from negative infinity to positive infinity forever. So our domain is going to be written with a parenthesis, negative infinity all the way up to positive infinity. And so we always write smallest, comma, largest in our domain and range. Okay, now the range, though, is the y-axis, okay? So if I think about the y-axis and my curve, on the example I drew, the bottom of the parabola is right here. So there is nothing below wherever my vertex is. And then it goes up forever. So when I look at my picture here, the bottom of my parabola is at 0 on the y-axis. So that means nothing below 0 on the y-axis is part of the range. So the very lowest number of the range on my parabola is 0, and it goes to infinity forever. So we would have a range written as, now 0 is going to get a bracket because 0 is an actual definitive number. Infinities are not defined concretely, so we need parentheses. So I'm going to do 0, comma, infinity, parenthesis. Okay, so that is graphing for these first parabolas. I would like you to try the next example. Now, I just realized I did not give you this table right here on your notes. Just draw yourself a T-chart with an XY, and I'd like you to try to do the exact same thing. So please pause the video and get as far as you can before coming back. Okay, so we are going to start with our table of values. So let me add in here my T-chart. My vertex, since it's in the form of this ax squared, is still 0, 0. So I'm going to enter that here. And then I'm going to do this 2 numbers below 0, 2 numbers above. And so when I go, I'm going to write out the first couple. So when I plug in, let's say -2, I'm going to have -1/2 times -2 squared. And so order of operations, -2 squared is 4. So I'm going to have -1/2 times 4. And when I multiply those together, I get a -2. Okay, so I'm going to go down the list. -1 will give me a -1/2. So I'm going to write that as 0.5. When I plug in a +1, I also get a -0.5. And when I plug in a 2, I get -2. All right, so let's graph that. Now halves, you're just going to have to estimate approximately half. So I'm going to zoom in here so I can use my pen easier. So -2, -2 is about right here. -1, -1/2. Oh, it's about, whoops, right there. Oops, why am I not able to draw? Try that one more time. Okay, -1/2. 0, 0 is right there. I don't know why it keeps doing that. +1, -1/2 is about right here. And then +2, -2. Oh, I just realized, nope, -1, yeah, right here. Okay, so then I will go ahead and make my curve. Whoops, I missed my dots. Try not to miss your dots. It's a little hard on my iPad here. All right, so axis of symmetry, it's still going through the origin. My axis of symmetry is still x equals 0. My domain, now my domain, another way to think about this is your domain, again, remember, are your x values. So if you think about this column right here, I'm plugging in x's. Is there any reason I can't plug in like a 10 or a 50 or 100? No, I can plug in any number I want. So when I go to do my domain, I'm going to always be able to do any number in the world. Okay, so -infinity to +infinity. My range, though, is dependent on my picture. So my very top of my parabola is at 0, and then it goes down forever. So the very smallest number is down forever, which is -infinity, and it goes all the way up and stops at 0. So my smallest number is -infinity. My largest number is a 0, and I will want to bracket around that 0. All right, well, that's all for today. I'd like you to make sure you've taken notes. You are welcome to watch this video as much as you would like, and either pop on during my office hours for questions between 10 and 11 or send me an email.